Now I'm gonna change some members. Those members, they are not actually connected to the barge for tension. They are only going to work with compression. Okay, so let's define them as compression members. I'm gonna change the view, display, orthographic, and let's pick this one, XC front view. And now I'm going to select the members and member properties. Let's select all of them. And define them as compression. Okay, and now go back to display, view, isometric. And now we're gonna change the boundary. Go to joint, fixities. I'm gonna choose just the C ones. The new fixity is 110000, and for the D ones is the new fixity is 001000. Now we finish everything we have to do in this model. Let's check if that's okay. There is no error. Go to mix, check model. Now SACS is talking about the groups of the members that are no longer in the model. We deleted all of them. Okay. Do you want to delete all user data? Yes. We can now save the model. Let's change this and use JKT. Save. Okay, we can close the model. Let's open up the model with editor. Let's take a look at this and check if the definitions are here. Here are the offsets and the compression only members. So it seems okay. You can close it now. And now we're gonna work in the loading file. Go to this cstate input file and open up with the datagen. The first thing we need to do here is to change the water depth and multi-line elevation to 0. We're not gonna use this. This line we can leave it for a while. Let's delete this one. All of this. All the loadings. And load combinations. Here you're gonna include the new loadings. Okay, the new load is called dead. And first we're gonna create the load condition. Here is. You can use this one and type dead here, then apply. Just that. Now I'm gonna include some weights here. The anodes, the dies, and the walkways. And here you're gonna tell SACS that it needs to calculate the dead load of the structure. Click yes. Okay, don't need to make any change here, so that's okay. Now the load combinations, gonna create a new one. It's called alls. Search for load combination input. Use alls. The load case name is that we have just created it, and the load case factor is 1.0. You can type a new one like this, LOS1, that again, and 1.0. You can just copy it and paste. Change the numbers. Okay, so we have 5 combinations here. Now we're gonna change the load case selection. The function we're gonna use for the gap element analysis. And here you can type the new load combinations of LOS1, LOS2, LOS3, LOS4. So this is our file. Let's save as loadout. So we can close it now. And let's create now the gap input file. Go to data gen, create new data file, pick up the gap element input file, metric. I'm gonna save as gap imp point that. That's okay. And go to insert input line, gap options. We don't need to change anything here. Go to insert input line, gap type override by member. Okay. And here, gonna use the load case ID. Those load case, the load combinations we created in the C-state input file, you're gonna type it here. LOS1. And we're gonna make the member become no load. Let's define the members here. It's D101, C101, D103, C103. Okay, and apply. We're gonna copy this and just change the numbers. Okay, it's faster. Just checking. LOS4, no load. D401, C401, D403, C403. Okay, that's correct. Let's save the file. You can close it now. Go to analysis generator. gonna reset it. Let's choose static analysis and static analysis with gap elements. Okay. Check this box. It added environmental loading options and the tubular joint check options. SACS model file with this one. The C state input file, this one. Oh, I chose the wrong one. It's this one. And joint can input file, it's the same. You don't have to make any changes here. And now I'm gonna edit gap element options. Use gap input file, yes. Gap input file, let's select it. Okay. And we're gonna make some changes to the element check options. Code criteria, gonna use the 9th edition and the API 22nd edition. The non-segmented elements use 2, segmented elements use 2. The report options go to override model, set joint deflection as yes, joint reaction as yes, and end forces yes, and UC ranges yes. Okay, go.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.